Row 1. Text, Notepad window, text editor, editing. Blank. Remember, this is not teaching man teacher. It is useful for recalling when exam coming man student. Just close eyes and listen. Based on G scheme for electronics engineering group. Subject, computer hardware and networking, 17,533. These are mostly important questions which is always repeat. Form top to end it, reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter.
Computer Hardware and Networking Chapter 4. 1. A. Describe peer-to-peer and client-server networks. 6 marks, 1 diagram, and 2 description each. Peer-to-peer network. Peer-to-peer, P2P, is an alternative network model to that provided by traditional client-server architecture. P2P networks use a decentralized model in which each machine, referred to as a peer, functions as a client with its own layer of server functionality. A peer plays the role of a client and a server at the same time. That is, the peer can initiate requests to other peers, and at the same time respond to incoming requests from other peers on the network. It differs from the traditional client-server model, where a client can only send requests to a server, and then wait for the server's response. In P2P networks, overall network performance actually improves, as an increasing number of peers are added to the network. These peers can organize themselves into ad hoc groups as they communicate, collaborate, and share bandwidth with each other to complete the tasks at hand, e.g. file sharing. Each peer can upload and download at the same time, and in a process like this, new peers can join the group while old peers leave at any time. This dynamic reorganization of group peer members is transparent to end users. There are an almost infinite variety of client/server networks, but all of them have a couple of things in common. All have centralized security databases that control access to shared resources on servers. A client can only send requests to a server, and then wait for the server's response. The server contains a list of usernames and passwords. Users can't log on to the network unless they supply valid usernames and passwords to the server. Once logged on, users may access only those resources that the network administrator allows them to access. Computer Hardware and Networking Chapter 4. 2. Thus, client/server networks possess much more security than do peer-to-peer networks. Client/server networks also tend to be much more stable. A. What is network topology? Explain star and bus topology with its advantages. NE2, definition. 1M, explanation of star and bus. 3M, advantages of star, NE2, and bus, NE2, 2M. Each topology of LAN's networks can be laid out in different ways. The physical layout, or shape of network, or the way in which network connections are made is called a topology. It refers especially the locations of computers, and how the cable is run between them. It is important to select the right topology for how the network will be used. Bus topology. In a bus topology, the computers are connected in a line, the cable is just one or more wires, pass it along from computer to computer. It is a passive topology. When one computer sends a signal up and down the wire, all the computers on the network receive the information, but only one, the one with the address that matches the one encoded in the message, accepts the information. The rest disregard the message. Only one computer at a time can send a message. Therefore, the number of computers attached to a bus network can significantly affect the speed of the network. A computer must wait until the bus is free before it can transmit. Figure 1 shows bus network. Figure 1. All computers are connected to common channel, bus. The important issue in bus networks is termination. Since the bus is a passive topology, the electrical signal from a transmitting computer is free to travel the entire length of the cable. Without termination, when the signal reaches the Computer Hardware and Networking Chapter 4. 3. End of the wire, it bounces back and travels back up the wire. When a signal echoes back and forth along an unterminated bus, it is called ringing. To stop the signals from ringing, you have to attach terminators at either end of the segment. The terminators absorb the electrical energy and stop the reflections. Cables cannot be left unterminated in a bus network. Advantages: simple, easy to use, and suitable for very small networks. Least amount of cable is required to connect the computers together, and therefore it is less expensive. Easy to extend a bus. 2 cables can be joined with a BNC barrel connector, allowing more computers to join the network. Star topology. A star network is one in which all the cables run from the computers to a central location, where they are all connected by a device called a hub. Figure 2 shows a star topology. Each computer on a star network communicates with a central hub that resends the message either to all the computers in a broadcast star network, or only to the destination computer. In a switched star network, the hub in a broadcast star network can be active or passive. Figure 2. In a star topology, the computers are all connected by cables to a central point. Advantages: it is easy to modify and add new computers to a star network without disturbing the rest of the network. Hub can accommodate multiple cable types. Fault finding becomes very simple. Single computer failure does not bring down the whole network. It is more flexible among the remaining topology. Computer Hardware and Networking Chapter 4. 4. H. List any 2 important benefits of networks. 2 benefits. 2M. 1. Help to enhance connectivity. 2. Networking help in sharing of hardware. 3. Eases out management of data. 4. Internet. 5. Data sharing. D. List important features of routers used in computer network. List 1M. Explanation. 1M. Each type, router. Router is a device that connects 2 or more networks. It consists of a combination of hardware and software. Types of router: 1. Static. 2. Dynamic. 1. A router is a specialized computer connected to more than one N/W. 2. Router operate at the N/W layer. 3. The primary function of a router is to connect N/W together and keep layer 2 broadcast traffic under control. 4. A router is typical connected to at least 2 N/W, commonly 2 LAN, or WAN or LAN, and its ISP N/W, or more N/W connects. 5. Routers are located at gateways, the places where 2 or more N/W connect. 2 types of router. 1. Static router. This router is hard-coded in the routing table. The administrative has to configure and set up all router manually. Static routing is the process of predefining router paths across data N/W, and can be used to conserve LAN and WAN bandwidth. 2. Dynamic router. Only the one street route has to be manually configured. After that, additional route are automatically discovered. The route is decided by the router on the basis of traffic and cost. They use specialized protocols to exchange information. Computer Hardware and Networking Chapter 4. 5. D. Explain the working principle of firewall. Diagram 1M Explanation 2M 1. A firewall is a part of computer system or network that is designed to block unauthorized access while permitting authorized communications. 2. It is a device or set of devices configured to permit, deny, encrypt, decrypt, or proxy all, in and out, computer traffic between different security domain based upon a set rules and other criteria. 3. Firewalls can be implemented in either hardware or software, or a combination of both. Firewalls are frequently used to prevent unauthorized Internet users from accessing private networks connected to the Internet, especially intranets. 4. All messages entering or leaving the Internet pass through the firewall, which examines each messages and block those that do not meet the specified security criteria. 5. A firewall blocks unauthorized connections being made to your computer or LAN. Normal data is allowed through the firewall, but all other data is blocked. There are several types of firewall techniques. Packet filter 2. Proxy server 3. Circuit level gateway 4. Application gateway. Computer hardware and networking chapter 4. 6. F. Explain importance characteristics of fiber optic cable. Any 3 points 3M 1. Fiber optic cabling can provide extremely high bandwidths in the range from 100 Mbps to 2 gigabits, because light has a much higher frequency than electricity. 2. The number of nodes which a fiber optic can support does not depend on its length, but on the hub or hubs that connect cables together. 3. Fiber optic cable has much lower attenuation and can carry signal to longer distances without using amplifiers and repeaters in between. 4. Fiber optic cable is not attached by EMI effects and can be used in area where high voltages are passing by. 5. The cost of fiber optic cable is more compared to twisted pair and coaxial. 6. The installation of fiber optic cables is difficult and tedious. 4. Define MAN. Give any two differences between LAN and WAN. ANS, 2M definition, 2M difference, any 2 points, short for Metropolitan Area Network, a data network designed for a town or city. In terms of geographic breadth, MANs are larger than local area networks, LANs, but smaller than wide area networks, WANs. MANs are usually characterized by very high-speed connections using fiber optical cable or other digital media. Computer hardware and networking chapter 4. 7. B. List classification of network on basis of geographical area. State the benefits of networks. List 2 marks, any 8 benefits 1/2 mark each, ANS. Computer networks are classified based on the geographical area into local area network, metropolitan area network, wide area network, campus area network, CAN, personal area network, PAN, benefits of network, resource sharing, reducing cost, application services, high reliability, improved security, centralized management. Email, flexible access. C. List networking devices. State the function of any 4 devices. Listing 2 marks, functions of any 4 devices 6 marks, ANS. Following are the various networking devices: hubs, switches, router, bridge, repeaters, gateways, modems, firewalls. Hubs. A hub is a small, simple, inexpensive device that joins multiple computers together at a low-level network protocol layer. Functions. It is essentially a multi-port repeater. Repeater receives digital data, regenerates the signal, and then retransmits the data. Switches. A switch is a networking device that joins multiple computers together at a low-level network protocol layer. Functions. It is used to transport the data to the specific computer. Routers. A router is a physical device that joins multiple networks together. Functions. It connects to similar networks such as LAN and Internet together. Computer hardware and networking chapter 4. 8. Bridges. A bridge is an electrical device which connects and passes packets between 2 network segments. Functions, it is used to send the data to the concerned segment, thus reducing excess traffic. Repeaters, a repeater is an electronic device that simply regenerates a signal. Functions, it recreates the bit pattern of the signal, and puts this regenerated signal back to the transmission medium. Gateways, gateway is a device used to connect networks using different protocols. Functions, a gateway repackages information to match the requirements of the destination system. Modems, modem is a device that makes it possible for computers to communicate over a telephone line. The word modem stands for modulator-demodulator. Functions, it is used to connect telephone lines, which uses analog signals, to computers, which uses digital signals, for data communication. 6. Firewalls. A firewall blocks unauthorized connections being made to your computer or LAN. Normal data is allowed through the firewall, but all other data is blocked.